Alright, so this is part 2 of the Technics ST-Z55 video. Part 1 was the review, testing whether it's even usable today, and this part is the teardown. There's nothing crazy and there's no restoration, no recap yet. I was just opening it up and seeing what's inside. And I recorded the entire teardown so you're watching it as I go, and there's not actually that much to disassemble, which is honestly kind of nice. To get it open, there are two screws on each side, so four total there. Then on the bottom, there are three more screws, so seven screws altogether. And once those are out, the top cover just comes straight off, and there's no clips and no weird plastic tabs or anything annoying. And as soon as you opened it, um, you can already tell this thing is old just by the smell and the way everything looks inside. It's dusty. There's like some sort of like sand or dirt. I don't know what that is. But there's nothing destroyed, and honestly, I've opened worse. Once the cover's off, you're basically staring straight at the main board. The layout is really straightforward. The board is held down with I think four screws, so I took those out next. At that point, it looks like you should just be able to lift the board and pull it out, but that didn't really happen. The board was still stuck because of the wiring, specifically the power cable going into it. There wasn't enough slack to flip the board or move it out the way, so I had two options: either stop and leave it mostly assembled, or desolder the cable and fully remove the board. I chose to desolder the cable and fully remove the board. So, this is the part where things get really ugly. I desoldered the power cable from the board, and I'm not going to pretend it was clean or professional because it was absolutely terrible. Like, it was very ugly. I didn't have flux, and I didn't have extra solder, and I definitely overheated the joint. You'll see it in the video right here. It took me a few minutes. I struggled. I even burned my finger, and I managed to slightly melt some plastic nearby. Oh man, I really have to get better at soldering. What the hell is this? Not my finest moment. After I got the cable off, I cleaned the area with isopropyl alcohol. It looks acceptable, not great, and not pretty, but it works. And at that point, the board finally came free, and I could actually pull it out and set it down properly. And that's basically the teardown. There really isn't much else to disassemble here. No stacked boards, no hidden modules, no ribbon cable hell. It's literally screws, board cable, done. The teardown itself is simple, and the interesting part isn't taking it apart. The interesting part is why this board actually looks like once it's out, and why it looks the way it does. Alright, so now that the board is fully out and on my desk, this is really where the video slows down, because the teardown itself was honestly simple. A few screws, desoldering the cable, and we're done. The interesting part is this board and why it looks the way it does. At first glance, I'll be honest, this thing looks like a power supply. Like, if you didn't know what you were looking at, you would assume this was just a big old power board from the 80s. There's like big components, random spacing, jumpers, chunky parts everywhere. But this isn't just a power supply board. This is basically the entire brain of the tuner. And that's the kind of first thing you have to understand. Sorry for the background noise. Electronics in the 80s all look like this. Back then, nothing was compact, nothing was minimal, and nothing was integrated the way it is now. If you wanted something to be stable or accurate and low noise, you didn't solve that with software or digital correction. You solved it with hardware and more parts, more filtering, more separation, and more space. So that's why this board looks so chaotic, and it's not random. It's spread out on purpose. Let's start with the thing everyone immediately notices, this huge ass inductor right here, labeled T701. This thing is massive. Like, compared to modern electronics, it's comically big. And the reason for that is because inductors used for power smoothing and filtering back then were physically large like this one. You couldn't shrink ferrite cores and windings the way we can today, and this inductor is part of the power filtering and regulation side of the circuit. And even though this isn't a standalone power supply board, the tuner still needs extremely clean, stable power. Any ripple or any noise, any instability ends up as a hiss, or a drift, or tuning issues. And yeah, I slightly melted part of the plastic right here, as you can see, when I desoldered the power cable. That's on me. Right next to that whole area, you've got a section that really makes it look like a power board. Big electrolytic capacitors, rectifier diodes, and thicker traces. And jumpers. There are a lot of electrolytic capacitors on this board, and most of them are way bigger than what you'd see today. And that's partly age, partly technology limits of the time, and electrolytics were bulky, and if you wanted decent capacitance, you needed physical size. And these are mostly used for smoothing power rails and stabilizing voltage across different sections of the board. You'll also notice there are film capacitors everywhere, like over here, here, and so on. These are super important for audio and signal stability. Film caps are more stable than electrolytics, especially for signal paths, and they don't dry out the same way. Back then, film caps were the go-to for anything audio or RF related where you didn't want drift or weird behavior over time. There are also some ceramic capacitors, mostly smaller values, usually for noise suppression and local decoupling. Alright, so at first glance, this metal box right here looks like it could be a power supply. And I'm not gonna lie, that was my first thought too. It's a big metal can, it looks bolted down, and it looks really important. But once you actually slow down and look at what's going on, it really doesn't behave like a power supply at all. There's no big electrolytic capacitors anywhere near it. There's no rectifier bridge. There's no transformer tied directly to AC. If this were a power supply, you'd expect to see at least something chunky, like huge caps or obvious high current parts, and none of that is here. Instead, when you look through the cutouts on the metal can, you can actually see what's inside, and that's where it clicks. You've got small copper coils, air core inductors, and ceramic capacitors. All stuff you'd expect in an RF front end, not a power section. These components are super sensitive and frequency critical, which already tells you this is radio related. That's why this is almost certainly an RF shield / tuner module, not a power supply. Power supplies are about brute force. RF circuits are about precision. The reason it's wrapped in this metal shielding is to keep electrical noise out. And the power section, the logic ICs, the display, even the button scanning all generate noise. And RF signals are fragile as hell, so one little burst of interference and your reception gets wrecked. The metal can blocks that noise and gives everything inside a stable ground reference and keeps those coils from drifting or getting affected by nearby circuitry. So it looks confusing at first, but once you know what you're looking at, this metal box makes total sense. It's here to protect the radio signal, not power the unit. Something else I really like about this board is how user-friendly it is, even though it looks insane. Look at this. The board literally tells you where the screws go. There's little screwdriver icons printed on the PCB so you don't have to guess. That's such an old school thoughtful design that you just don't see anywhere anymore. Then there's the sheer number of resistors and diodes. Like, there's no way around it. There are a lot. Again, this comes down to design philosophy. Instead of doing everything inside a single chip, Functions were broken down across discrete components, biasing, filtering, limiting, detection, all of it handled with resistors, diodes, and transistors. And instead of complex multi-layer traces, you'll see a ton of these jumper wires. Back then, multi-layer boards were expensive, and jumpers were cheaper and easier. So if a trace needed to cross something, they just ran a wire. And it looks really messy by modern standards, but at least it worked. Now, moving toward the logic side of things, you'll see several IC chips. One thing you'll notice printed on the board is PLL controller. PLL stands for phase locked loop. Correct me if I'm wrong, I think that's what it stands for, and I think this is a huge deal for tuners like this. Instead of analog tuning drifting all over the place, the PLL locks the tuning frequency to a reference, which is why this tuner is stable and accurate. And that brings us to something really important. The quartz crystal oscillator, right here. This is the time base for the entire tuner. Quartz crystals vibrate at a very precise frequency, and that frequency is used as a reference for the PLL system. That's why the front panel proudly says quartz synthesizer. Without this crystal, the tuner wouldn't be precise. Stations would drift, and presets wouldn't line up properly. This is basically the heartbeat of the tuner. And it's funny to think that a single little crystal is responsible for all that accuracy. Over here, you also got the preset button board, the 1 through 16 preset tuning buttons. That's a separate PCB connected to the main board, and again, very modular, very serviceable. If something went wrong with the buttons, you didn't throw the whole unit away, you fixed it. Then here you have a display. This is a 7-segment style display, like a calculator or a stove clock or an old stereo. It's not meant to show graphics, it just shows numbers and indicators. You'll see labels like KHZ, MHZ, memory, AM, MW, FM, LW, everything it needs. Nothing it doesn't. Is it primitive? Of course. And does it matter? No. The tuner doesn't need a screen, it needs clarity. What really gets me about this whole board is how hardware heavy it is. There's no attempt to hide complexity, everything is right there, and you can trace paths and you can follow logic and even understand sections. Compared to modern boards, this thing feels really massive, inefficient, and overbuilt.